Facade design is a complex engineering challenge. In addition to a multitude of complexities, designers must account for both a vapor barrier and thermal loads from external conditions such as weather. Physics simulation, such as thermal analysis, helps engineers understand the performance of a facade before it's built to optimize for metrics such as the R value, which is a measurement of the insulating capabilities of construction assemblies. In this video, we'll show you how we used a detailed virtual construction facade model from CATIA to study the heat transfer of the various materials without any data transfer by using the Simulia apps integrated into the 3DEXPERIENCE platform. First, we'll start with the building model. This particular project was modeled in CATIA 3DEXPERIENCE. Models from other BIM or CAD platforms can be imported and used for the thermal analysis as well. Opening up an individual panel, we have incorporated details such as the mullion profile, multi-layered infills, and even the gaskets. In addition, we've applied all the materials and their associated engineering properties to be used in the simulation, such as steel, glass, and rubber. In order to conduct the simulation, the geometry must be first subdivided into smaller elements to enable finite element analysis equations to be used. The panel is automatically meshed and can be refined using Simulia's tools, giving the user complete control of the mesh size and shape for each part of the assembly. In this demonstration, we'll be using the tetrahedral mesh shape. Once the meshes are set up and boundary conditions have been set, Simulia will automatically identify the interactions between the interfacing elements and conduct the analysis for contact, heat flux, and radiation for all parts, materials, and interactions. In this steady-state simulation, we're modeling heat transfer from the exterior of the building moving inwards to understand the energy loss of HVAC cooling through this double-glazed facade panel. Playing the simulation, we can visualize the steady-state effects given the boundary conditions, geometry, thermal conductivity of the materials, and the energy sources provided. A color gradient representing the temperatures and thermal energy transfer is overlaid on the model over a step time defined by the user. Using this methodology, we can identify the final steady-state temperature and how long it'll take to reach this point. The quantitative data can be output via spreadsheets and graph plots of the temperature change of each component over time, which then can be used to estimate U values for this panel design. Some of the advantages of using this methodology is that we can first parametrically design and create fabrication detailed facade panels with their respective materials using a high level of automation in CATIA. For example, if you want to test 1 versus 2 versus 3 infills and change the materials for each of the infills, we can generate all the variants of this using automation. Then within the same platform, without any model export, you can mesh and simulate all the variants of the panel in question, enabling designers to study more possibilities with less engineering time. With seamless integration between CAD and simulation environments, we reduce the lead time for simulation feedback and optimization by being able to sort and filter the most promising design genealogies. Lastly, by using Simulia, we can either compile the simulations using our local machine's computing power, or use simulation tokens for a small fee to utilize a remote cloud server with more processing power. If you like this video, please give us a like and subscribe. And if you're interested in learning more about CATIA, Simulia, or our automated modeling and simulation process, please visit the link in the description below.